Okay. Good morning, children. Today we are going to discuss at the beginning general methods of preparation of alkanes. General methods of preparation of alkanes. Alkanes are hydrocarbons with formula CnH2n plus 2, and hydrocarbons are excellent fuels. So how are these compounds prepared? Okay, that I'm going to discuss. First method is from unsaturated hydrocarbons. Unsaturated hydrocarbons like from alkenes. Say this is the simplest alkene. So hydrogen in presence of nickel as catalyst. It can be also platinum as catalyst. It can be also palladium as catalyst. So in presence of this catalyst, hydrogen gets added here, and it becomes CH2, H. So you see these atoms get added here, and this is a alkane. So this is a addition reaction. So in this way, from alkenes, starting with alkenes, we can prepare alkanes. So another reaction let us give is CH3CH double bond CH2. This is also an alkene. So hydrogen, same in terms of nickel or platinum or palladium, any one of them. So we get CH3, CH, CH2, here H, here H. So added. So now in this way we can also get it from alkynes. So I'm showing you that. Suppose this is our alkyne. Alkynes are having carbon-carbon triple bond. So hydrogen, again in presence of nickel catalyst. Now since here it is triple bond, per molecule of this, 2 molecules of hydrogen will be added. Or per mole of this, 2 mole of hydrogen will be added. So that's why I am writing it here 2, and the product will be CH. This unit is as before, and 1 hydrogen will be added here, 1 hydrogen will be added here, another will be added here, another will be added here. So this is the alkane. Say another case, CH3, C triple bond CH plus 2H2 in presence of nickel. So we get CH3, CH2, or product. So this is first way of preparation of alkane. Now second method that we are going to discuss is from halo compound. From halo compounds also, organic compound where halogen is present, from such compounds also we can get alkane. Okay, I am showing you how it can happen. Okay, So suppose CH3 Br. This is a halo compound. This name we can call it as bromomethane. So when halo compound is treated with zinc and acid, that we write like this way. So halo compound is mixed with zinc and acid. This is the style we write in organic reaction. Zinc and acid. Zinc react with acid to give hydrogen gas. So that hydrogen gas that will be produced, that I am writing it here. So zinc and acid giving hydrogen gas, that will react, and the product will be CH4 plus one H will come here, and another H will go with this H here. So this is alkane. Suppose CH3 CH2 Cl plus H2 zinc H plus. So we will get here CH3 plus HCl. So this is how we can get alkane. And one thing here, this reaction does not happen with fluoro compound. Okay, does not happen with fluoro compound. Suppose CH3 F plus H2 Zn H plus, there occurs no reaction. Okay, and just a minute here. I think okay, so this is now second method is in organic chemistry we will get a lot of name reaction. Okay, name reaction. So now one first name reaction that will come is Woods reaction. By Woods reaction also we can prepare alkanes. By Woods reaction we can prepare alkanes, and so what is the method here? A halo compound is treated with sodium metal in presence of dry ether. Halo compound is treated with sodium in presence of dry ether, and we get this one CH3 plus NaBr. What happens in this reaction is this fragment joins with another fragment of alkyl group, and we get alkane. Okay, now you see in organic chemistry balancing of equation is not so important. Okay, if you write this in exam, marks will not be deducted for balancing. Okay, so now if you suppose you want to balance it, then of course you can write it like this: 2, here also 2, here also 2. So by Wood's reaction we can prepare alkanes. I am showing you another case. Say CH3, CH2, Cl. Look at chloroethane plus sodium in presence of dry ether. You know, dry ether is used as a solvent here. This substance, this halo compound dissolves in dry ether. Okay, it does not dissolve in water. That's why we have to take as solvent dry ether. Dry ether means ether in a liquid which does not have any moisture in it. No moisture, free from moisture. That's called dry ether. So here again, this two fragments of this will get joined. So we will get this alkane. So you see, this is one fragment and this is another fragment that has joined. And of course another byproduct will be NaCl. So this is Wood's reaction, and your suppose I am giving a question to you, you try to get the product here. Okay, in exam like this type of question comes. Suppose CH3, CH, CH3, CH2, I. So it's also a halo compound plus sodium in presence of dry ether. So you have to understand it is a Wood's reaction. You try to write the product yourself. Okay. Now next reaction, next method by which we can prepare alkane. It is we can do so from carboxylic acid. From carboxylic acid, we can prepare alkane. Carboxylic acid, are compounds of this type. RCOH, these are carboxylic acid. So from this type of compounds, we can get alkane. Okay, so here also there are two methods are there. One is by soda, lime, decarboxylation. By soda lime decarboxylation. Okay, so what is the soda lime decarboxylation? It is a we have to take sodium salt of this compound. Sodium salt means this compound, if we treat this compound with sodium, carboxylic acid, when treated with sodium, we get sodium salt, and this is the sodium salt, Na+. Sodium salt, it is heated with soda lime. Okay? heated with soda lime, a mixture of NaOH and CO, the solid. This is also solid. These are all solid. It's heated strongly in a test tube. Then we get alkane. Now, how we get alkane? You should remember this R part combines with this part, and we get alkane. This R combines with this H, we get alkane, and the side product that we get, it is Na2CO3. So suppose by this method you want to prepare, say, suppose you want to prepare by this method this alkane. So and suppose you are asked to write the equation. So you can go like this: CaO delta NaOH. So which compound you have to take here, that you have to decide. Looking into this, so you see it will be, I think, like this: CH3, CH2, CH2, double bond O minus, and A plus. So this compound, on heating with soda lime, will give you this alkane. Now another method is again a name reaction. Again a name reaction that will come. That is by coal-based reaction. By coal-based reaction also we can prepare alkane. So what it is done, we take a container tank where we take here sodium or potassium salts of carboxylic acid. Sodium or potassium salt of carboxylic acid we take in water, and these are two metallic plates. Electrodes, and they are connected to source of current. This is minus, this is plus. The minus plate is called cathode. The plus plate is called anode. And when we pass current here, we will get alkane. And where will we get the alkane? We will get the alkane at anode. At anode we will get alkane. Now how we get anode, at the anode we get alkane, that I am showing you by taking an example. Suppose we take here this one, CH3, C double bond O minus, Na plus. Suppose we have taken this compound here. Okay, then what will be the reaction, that I am showing you here. Now there will be negative ion. Okay, this negative ion will be there. This negative ion will be there in the solution, and this negative ion will, when current is being passed, it will migrate towards anode, because anode is a positive plate. This ion will migrate towards anode, So at anode, what is happening? This ion, now let me show by the lone pair of electrons. Here there are 3 lone pairs, double bond oxygen has 2 lone pairs. So what will happen is this one will lose an electron. This one will lose an electron and it will become CH3, C double bond O. Yes. So you see here, one electron is being lost. That happens at the anode. And after that what happens, there is another step that happens that you should know is that this bond, look at this bond. This bond has 2 electrons. This bond has 2 electrons. And one of the electrons from here comes here. One of the electron comes here. And this unpaired electron also comes here. So here at this place 2 electrons are coming, and what will be formed? Carbon dioxide will be formed. So this CH3 and dot, so CH3 dot will be formed. This is methyl free radical. Methyl free radical, I had discussed about free radical. Methyl organic intermediate, this is one type of organic intermediate. Methyl free radical will form, and this will be carbon dioxide. Okay, so at the anode many methyl free radicals will be formed, and then these methyl free radicals will combine in pair. In pair they will combine, and we will get what? Suppose this is a methyl free radical, this is another methyl free radical. Okay, they will combine in pair, and these 2 electrons will form a bond. So at the anode here we will get ethane. So in this way we can get alkane at the anode. And let me tell you very quickly what happens at the cathode here. Okay, what happens at the cathode here? At the cathode, there is formation of hydrogen gas in the cathode. So this, there will be hydrogen ion from water. Okay, that will gain electron from H atom. H atom will combine in pair to form what? H2 gas. So this is by Kolbe's reaction we can prepare alkane, and you can see this reaction goes by free radical formation. So children, this much for now. Okay, in next video I will be discussing about the properties of hydrocarbon, properties of alkane rather, physical property and chemical property of alkanes will be coming up in the next video. Till then, good night. Sorry, till then, have a good day.